Hey, thanks for watching. So today I'm going to be streaming. Earlier today I streamed, um, trying to get the pattern I'm looking for. So let's pull up our PowerPoint. Analyses. Ooh, that's hot coffee. So we're looking at this analysis. What I want to do is I noticed that in this region, oops, I guess this is transparent. Um, in this region down here, bets tend to win. So this is all the data we're looking at. If we zoom in a bit, we get this data. We notice that most of the data falls along this blue line, which is the ideal change in odds. The change in odds for each team should be the same. Um, and then we notice down here there's all this blue data. Um, if we focus in on it a bit more, and then draw a region around it, you could see that if we say, hey, let's take uh, every every bet that falls in this region, then we see that these are all wins. This is for the home team. And so if we were to bet on the y-axis here is how much the odds are swinging in for the home team, and on the x-axis is how much the odds are swinging for the away team. So when we see that the odds swing fairly heavily for the home team, and then we're past this point, basically in this region, it's almost all wins. And then in this region, it is all wins. So now, how? So then the question becomes, how do we define these two regions? First of all, we don't want. So the first thing is we don't want to define the region with two lines and the first line being this line. That's because if we take all the bets that lie under this line, we're including all of this data in orange here, which are losses. So we want to trim those out. Now, there's a certain point. If we move down here, we see there's a certain point where if we stay just below this line, we can basically cut out all of these losses. Um, so I looked at that. Oh man, did I not? I have the worst habit of not saving this PowerPoint, and then I end up having to do it again. So, the line that I'm outputting here, let's go look at our code and see if we could pull it up. Let's get analysis one. Um, okay. Now if we run it, what are we doing? Plot home versus away odds. Plot analysis, annotate is equal to true. So I think, oh yeah, we have well, let's just run this. I'll just show you right now what this code outputs. So let's run the file analysis1.py. Okay, so let's go to our directory, spread history data, and then Python 3 analysis1.py. Okay. Oh yeah, I gotta almost forgot. I have to pull up the stream and remember to reply to chats that people send. Because I've been bad about that in the past, but I killed it this morning at answering chats. So go ahead and put something in the chat if you're thinking anything, and I will reply. I'll reply as soon as I see it, which should be really quick. All right, so we're looking at this trend. Oh yeah, and here's our data. So I said, hey, I want to go ahead and look at this data. Now this is all data. It's the same as the last plot. And you see that if we, so how did I calculate this line? This red line here is from, this is, so the sports book wins at 55% of the time. If the sports book won at 50% of the time, then we could represent that with the blue line here. But if the sports book wins at 50% of the time, they don't make any money. So they don't want to only win at 50% of the time. They want to win slightly over 50% of the time. 55% of the time. And that's how sports books make money is they win 55% of the time. And then the equation is just get people to bet. And the odds are always moving so that the sports book wins no matter what. So if there's a lot of money on one team, the odds will switch to be more in favor of that team and less in favor of the other team. And then that will induce bettors to take the other team on the bet. So Vegas always wins at a 55% rate. So that's what this red line symbolizes here. Now, one interesting thing about the red line, we know that this is a good line because look at all the data it cuts out. It cuts out all of these orange dots right here are cut out. Both of these are cut out. And so if we just say, hey, get below this line and get this region here, then we're on all blue. Um, so um, Now our question is, what would be ideal? If we just cut out all of these losses and say get only the region where there are wins, then we might be cutting out a lot of potential bets that we could place. You could imagine that you could also draw the line like over here, and if you include all the bets that are below the red line but to the right of where my cursor is right now, I hope you can see that. So let's get all the bets to the right of my cursor and below the red line. And that very well could be more profitable than just getting all these bets in only the winning region. So we want to say, hey, let's optimize where this line is drawn so that we make the most money from the bets. And so that's what I'm going to do right now. So I've gotten plots with this red line here, but I haven't retrieved all of the data. So sorry, I've gotten plots with the red line, but I haven't gotten plots with the vertical line, and I also haven't marked the data. So let's go into this analysis file. And so what are we going to want functions for? Here's my, oh, don't have it pulled up. So here's my Trello board. Let's go to the sports betting board. Okay, and figure out how to define a region. Now that's good. Right function that passes in an argument. So this we could say is now bottlenecked. And it's bottlenecked until we finish our current to do. So what are we doing right now? Figure out how to define region. Why do I have that twice? So let's go ahead and get rid of that one. Now in order to define region, write code figure out how to define the region. I guess we are still working on that. So we want to write a function that passes in an x-intercept for the vertical line. Okay. So this is plot analysis. We can say what do we want a function for? We want a function for get wins in region and pass. Now, Shapely is a package that I think gives us Python test whether a point is in a region. I don't want it to be in a polygon. I could make a massive polygon and say, the region is defined by this line down to here and this down to here, and then extend the lines very far and make a huge polygon. Get wins in region. So the first line is hard to find. So x int. Now, x int should be a float. X int is a float that specifies the x-intercept of the second line. So that's the only thing we pass in. Now, let's see what they say here. Shapely, yep. Okay, so this should be pretty easy. So the first thing is to get the intersection in the lines. So, yeah, so here's what we're gonna do. Let's go to open our notepad. All right, so this is just a running file I have with notes. Let's say this is 12, 11, 23, live stream 2. All right, so what are we gonna do? We're gonna define a polygon with the following points. So the first point is the intercept of vertical line with our offset line is the first point. Now the second point should be the vertical line extended to minus. So this is the odd swing for the home team. We could say, hey, no team's going to have an odd swing of minus 2,000. So we could say, extend it to minus, so extend the vertical line to minus 2,000. Oh, this would actually be easy. This is just x-intercept minus 2,000. Okay, now our other point should be the intercept line extended to x equals 2,000. And that's because we're not going to get a positive odd swing of 2,000 either. I mean, it's extremely unlikely. And then our last point should just be, so let's call each of these let's name each of these points. So point 1 is that. Point 2 is this one. Point 3 is this one. And then finally, point 4 is just point 2, point 3x, and point 2y. So that's how we define our polygon. So let's just say get. So if we want to get region. Now here's the question: do we want to build out a class? Yes, we do. So let's start a class. So for a class, we're going to call this class analysis1 trend 3. Now, what's that when I call it all lowercase? Analysis1 Okay, so our class is analysis 1 trend 3. Now, when we initialize the class, um, we want to do training years and then also test years. And then we want to say self.data is equal to um, right. So let's say self.data, self.all data is equal to pd.read Excel, and we're gonna just read our main data file as we always do. Um, all right. Now for get analysis, get analysis of seasons. Okay, let's just do initialize. Now get analysis. Um, so let's say get wins. Define. So let's make a function for separating data. Um, and we want to do training seasons, which should be a list, and test seasons, which should also be a list. Now we're gonna do self dot all right, so we're gonna do training data is equal to self dot all data. Um, yep, that's right. So add self as an argument here. So training data equals self dot all data. Now for season in training seasons, um, all seasons is equal to np.arange 2007 to 2022, and we're gonna put it into a list. Now for season in all seasons, if season not in training seasons, training data is equal to training data dot where training data dot year is not equal to season. And then we could do the same thing for test data. Training data is equal to test data is equal to all data. If season not in training seasons, take it out. And then drop NA. All right, now we also want to say if season not in test seasons, if season not in test seasons, um, so if the training season, if season's not in test seasons, then test data is equal to test data dot where test data dot year is not equal to season. And then we can say self dot training data is equal to training data, and self dot test data is equal to test data. Now let's say define get region, and we want to define the region based on the x-intercept. And so returns a polygon defined by the two lines. Defined by the 4 points from our two lines. And the 4 points should just look like what we wrote in our notepad. Okay, so point 1 is the intercept of vertical with our offset line. So how to find where two lines intersect? So our first line is offset by what? 22.2 repeating was the value. So finding intercept of two lines. Line 1 is defined as y is equal to negative x minus 22.2 repeating. And line 2 is defined as y is equal to whatever our x-intercept is. Our specified x-intercept. So we can say that the intersection of these lines is when x int is equal to minus x minus 22.2 or x is equal to basically the opposite. X minus x int minus 22.22222. Okay, so that's what our x is, and then our y is just equal to no, that's what if we set the y's equal x int equals minus x minus 22.2222. I'm just trying to think. It has to it has to it has to have the same x, but also the same y. Why am I having so much trouble thinking about this? Well, okay, so what's y? X should just be x int. Um, so whatever y is, at any point, oh, y could be anything, but x is always the same. Yeah, so for the x to intercept, then it must be x int. Otherwise, it wouldn't fall on that vertical line. Now, the x has to be that. So if we set the x as equal, then we say x equals minus y minus 22.2 repeating. And then this one, x is equal to x int. So x int is equal to x int what we have is y is equal to minus x int minus 22.2222. So point 1 is equal to x int and then minus x int minus 22.222222. Two repeating. So we have point 1. Now point 2 is easy because it's just x int and then minus 2000. Okay, point 3 is a little bit harder, but not very hard. So if we extend that out to x equals 2000, then it's just 2000, and then the y value is, so the first equation, y equals minus, okay, minus 2000 minus, so 2022.2 repeating is point 0.3. And then point 4 is 0.3x. Point 0.3 of 0, and then 0.3 of 1. Okay, and then let's make a polygon from Shapely. Okay, now return polygon from Shapely import polygon. From Shapely dot geometry import polygon. And we are also going to want point. Now let's do get wins in region. Plot analysis. All right, so separate data. Now we've got get region. Now we can say define plot region. Excellent. Now we can say, let's see how to plot a polygon with Shapely. XY equals poly1 dot exterior. Okay, so that should be easy to plot it. So let's plot region. Now, bounding box is just equal to, polygon of point 1, point 2, point 3, and point 4. And then we're gonna say, okay, plot region x int bounding box is equal to self dot get region of x int. All right, and then add self as an argument here. And I gotta go to the bathroom. I'll be right back. All right, so we defined our bounding box. Now we want to plot it. So first we want to say get analysis data, and we pass in the seasons. So let's say get analysis. Okay, get analysis of that region. I guess we'll have to pass in the seasons as well. Um, and the data will just be the data we already have. So, and then, okay, so wins comma losses is equal to get analysis of data and seasons. Get analysis of self dot training data and then seasons. All right. And then so we have wins and losses. We already have matplotlib, so let's go down here and say plot. Let's actually scatter. In wins, how did we do the plotting before? plt.scatter data. Right, okay. So let's just do the same thing down here. And this will just be, we'll call win-loss data, so we don't get it confused. And then for item in win-loss data, for item in win-loss data dot keys, plt for item win-loss data dot keys, we're gonna do this scatter plot. Now we're not gonna plot that line because we'll have a polygon. Okay. Win loss data. All right. Then you're gonna scatter that. Then don't have to worry about plotting the line. Do have to worry about the maxes. plt.plot, so don't worry about that line. Do worry about getting the min and the max. All right. All right. Now, all right, we have that. Right, and then, all right, so get points of a polygon, polygon1 dot exterior xy. Nice. So, polygon x, polygon y. Yeah, polygon x, polygon y is equal to polygon1 dot exterior dot xy. So bounding box dot exterior dot xy. So now we have that, and then we can say plot polygon x and polygon y, and then call it label is equal to bounding region. Okay. And then set the limits. Okay. And should we be good now? Set the limits. Oh yeah, add the legend. All right, add in the legend. Let's just show it. We don't need all the fancy stuff in there for now. And then let's say test region automation. Test region plot is equal to 1. Go up here, get rid of this one. Now for if test region plot is equal to true, if test region plot is equal to true, then we're going to say analysis 1 trend 3. All right, equals analysis 1 trend 3. And then we're going to say analysis dot separate data. Analysis dot, okay. So we can say analysis dot separate data, and then training seasons is equal to 2009. Let's just say np.a range of 2007 through 2016 dot to list. And then we can say test seasons is, we're going to test 2016. And then we're going to say analysis dot plot region of x int. Oh, plot region x int seasons. Analysis dot training seasons. So we'll say analysis dot separate data, analysis dot plot region x int is equal to, what do we want to try as our test for the x int? Let's say it's equal to 100. Okay. X int is equal to 100. Right, and then seasons is equal to analysis dot training data. All right. Now that should work, I think. Let's try plotting it. Hi, Mutaz Basha. Are you good? Mutaz Basha says, hello, are you good with Julia? I'll read it here. I am trying to learn it for my bachelor work, but I am beginning. Can you please explain ML with Julia? Unfortunately, I don't know anything about Julia, Mutaz. Sorry. I don't. Unfortunately. Um, why not Python? Python is, Python, everyone says Python's the best for machine learning. So, yeah, what's Julia and why are you using Julia? And should I use Julia? Maybe that'd make this easier. Um, yeah, do you know what Julia's good at, Mutaz? Um, okay, so back to the polygon. We're going to test this. And let's try to plot it. Python 3 analysis 1.py. Um, oh, got to put a comma there. Let's run it. Get region takes one positional argument, but two are given. Get region of xn. Oh, okay, so this is because we always have to remember that when you're writing a method inside of a class, you always have to include self, because otherwise it's going to expect the wrong number of arguments. It always passes self as an argument. It's similar to Python. The work was with Python but changed to Julia. It's easier and more dynamic and good for machine learning. Nice, thanks Mutaz. That's good to know. We'll we'll pin that so that other people who join this stream know. Man, this is such a pain in the butt trying to pin a comment. Oh, nice. Nice. So thanks for the info, Mutaz. We might look into Julia. Let's put that there. All right. So C++, yes, I do use C++, but I'm not using it for this project. Hi, Petru Radu. How do I like this? I don't know how to like it. Anyway, thanks, Mutaz. Yeah, C++, I write code in C++. It's awesome. Python's just easier for prototyping. Python, you can really get things going extremely quick. It also has a huge like open source community. There's people build Python packages for everything. So basically anything you want to do, like for instance, this or a good example is this polygon package here. I'm like, okay, I have these points. I'm going to draw this region. I want to know if a point's in the region. And I didn't have any idea how to do that with math. All you have to do, if you're using C++, there's lots of good packages. You might be able to do it. But since this open source collaboration on Python is so much, they just have so many packages. So all I have to do is search it. Boom, we got up here. We have a package we can use, put it into the code, and we can implement it in like a few minutes. And then the downside of Python is that it's not good for optimized code. It's often slow a lot of the times. Like on here, my project board, one of the main things, speed up code. Yeah, literally because it's Python, so it's slow. List comprehension is slow. But then lots of things in Python are built on C++. So like the famous example is NumPy. If you go to NumPy, if you're using any NumPy functions, you're really using C++ functions. So you kind of get the ease of Python with some speed of C++. So they do have optimized libraries. So Python for me is just kind of all around the best for prototyping things. Once I have stuff prototyped, if I have to get it to work in like a real-time application, or if there's something else, like if you're doing a lot of optimizations and you're going to need to run a lot of code. Like sometimes sometimes you'll run code on supercomputers and it'll take like 2 days to run. So if you're doing that kind of stuff, you obviously don't want to do it in Python. You want to do it with C++. But for this stuff, data analysis, Python's just the absolute best for it. But yeah, I have to come up with a C++ project to work on. How do I? Well, the other guy had good. Mutaz had good advice, so he'll stay as the pinned comment. But thanks for the input, Petru. Yeah, C++ is awesome. I need a project with it. And we might do C++ with this if we need to speed up the optimizations. So back to this. Where's our error? So bounding box, file analysis 1.py, and get region. Okay, so something's wrong with how we're defining that polygon. Oh, you need to do a list of points. Okay, so pretty sure these just need to be in a list and then we'll be good. All right, let's rerun the file. Okay, plot region x min x max. So we're getting an error in nan min. Zero size array to reduction operation minimum, which has no identity. All right, now wins, losses. Thanks for the answer. Petri, you should try learning. So Petri says, thanks for the answer. I'm a beginner when it comes to C++, and I might learn Python later as well. Have a good stream. Thanks, Petri. Hey, before you leave, you should learn Python before C++. Python's better than C++. Way more flexible. You could do way more stuff with it. But we'll pin that comment. That's a nice new comment. All right. So we're trying to figure out. Okay, so there's a zero size array. So something's going wrong when we're trying to get our minimum and maximum. So let's put the debugger in here and go check it out. So run the script. All right, now what's wins of 0 look like? Okay, so that doesn't return anything. What about seasons? Seasons. So it's not training data, it's training data. Okay, so we're gonna want to train this or save this training seasons variable is equal to training seasons, and also save the test seasons variable. All right, now we can go down here. Instead of training data, we can do training seasons. All right, and then let's comment out that debugger line so it doesn't get caught there every time it goes through in case it works now. All right. And does this work? Nice. Great. So yeah, we get our bounding box. Now let's make sure we get the whole box. Nice. So it, yeah, just draws the extra big box. We could extend this out if we want. Yeah, let's extend it out instead of, let's do 20,000 and then we really won't have to think about it at all. And add a 0 there. Okay, so I'm mainly using C++ for college, but I'll give it a go after the semester ends. Thanks again. Yes, college. Good luck getting through that. That's college is hard and tough, but it's also fun and worth it. And if you're trying to force yourself to do programming, you're not going to have a fun time. You should try to get some project that you want to do. Hey, I want to accomplish this thing. I want to make a website. I want to, uh, like me, I want to make money betting. I write Python code every day, all day for work. So this is how I'm getting better at coding, is just making myself do it with an interesting project. So we've got the region. Now what do we want to do? We want to get bets in the region. So um, let's say define get bets in region, and we want to pass in bets. Um, okay, so um, what will the bets in the region look like? Okay, so for bet in bets, we're gonna get a point, an X and a Y. Um, yeah. Okay, so yeah, we'll worry about how to rearrange the other stuff later. So for now, let's just say, let's assume that the bets are in point form, each one's an X and a Y. Now for bet in bets, bet, how do we test if something's in a polygon? Shapely. Um, Polygon dot contains point. Okay, so it's true if it contains it. So we're going to say region bets is equal to an empty list. Now for bet and bets, if if region, so self get bets in region. So all right, so we're gonna say get bets in region, and I guess we just want to pass in bets, and we also want to pass in region. Um, Region bets is an empty list for bet in bets if region dot contains point of bet. What is that over there? If region dot contains point of bet, so if the bet is in the region bets dot append, um, if if the point's in the region, then append the bet to the region. Okay, now if the bet's in the region, add the bet. Now, I guess we just want to return region bets. Now we can say, all right, plot region. Okay, then region losses is equal to region losses is equal to of self. Region losses is equal to self dot get bets in region, and the bets we want to look at are losses. Okay. And then the region is just the bounding box. Now, okay. Let's add in this debugger so we can see how we have to change the win and loss data. All right. So wins, type wins. So wins of 0, wins of 1. Are we not dropping the data at some point? Get bets and region. Win-loss data. Self.training data. Training data equals training data dot where. Training data dot year is not equal to season. Definitely want to drop that. Okay. Now where were we? Oh yeah, we're trying to figure out how to rearrange the data. Dot values. Can we zip it together? Okay. Okay, let's try zipping it. Zip. And the first things we want to zip wins of 0 dot values dot to list. All right. A equals zip. Yeah, I mean, we could just, okay, so for win, for C win in wins of 0, for C val in wins of 0, my wins is equal to, um, here we could say my wins is equal to a blank list. Now my wins dot append, first we want to append val, and then we also want to append wins of 1 of C. I had a similar project. Hi Gojira. I ended up creating a model around a tweaked version of ELO rating applied to teams instead of the actual win losses. Yeah, I noticed that is pretty popular. I noticed there's 538 ELO data. They had a model that where they found ELO data going back to like 1920 or whatever. And that had been up since, I don't know, 2014 or something like that on 538. And then they got rid of it and you could still find the ELO data, but you can't find their model, and their data only goes to 2021. And then, if you're interested, I found this site with a guy who does ELO data. But again, I don't know what his model is, and I just don't know what to make out of these numbers. Um, you what where did you get your data from to build the ELO data set? Did you use the NFL API? No, that's the most, no offense to everyone else, but that's the most exciting comment. Oh, man. Also, George, didn't see that. If the data being used is old, wouldn't it be outdated and not contribute to any accuracy in predictive decisions? How do you reply to a, I don't know how to reply. Anyway, uh, George, that's true for, no, not, uh, that's not true. With for the data, the old data being used, that's what we use to train our model. And then the game changes as time goes on, so models with certain old data stop being valid, but that's why you need to continually update the models to validate them. And that's also why the approach I'm taking is, and I think the standard approach to take is you have a series of models. You aren't betting based off one model. You have like 2 dozen models that you're betting off of. And then you're constantly checking them and validating them. And if models fall out of favor and stop working, then you cut the model. But old data, you need to train on something. So you need some old data. It can't all be recent data. Um, so Gojira, you're talking about your project. I used it with Premier League football. Nice. Created my own ELO calculator where I tweaked the parameters depending on the importance of the match, league match, Champions League, cup match, etc. So each team had an international ELO and a country competition ELO. Damn, that's cool. So what'd you use to optimize it? Do you use machine learning to optimize the ELO parameters? Like, did you use Bayesian or Bayesian, I guess they call it. To use Bayesian parameter inference, and just looped all the matches. Yeah, so how did you tune the hyperparameters of your model? Um, oh yeah. Well, I'm wondering how did you get so like you tweaked ELO, how did you figure out how to tweak ELO? Did you just manually do it and see until you got good results? Oh, ML only applied on the prediction. Oh, I guess I'm kind of confused. I guess I have to look up ELO more. So I thought if you're using ELO, you're not using a prediction model. Do you feed the ELO ratings into the prediction model? And I guess I'm wondering how do you figure out how to tweak the parameters? Yeah, okay, you fed the ELO to the prediction model. That makes sense. I guess I'm just confused on how to tweak the parameters, but that's not so interesting. I could figure that out. Um, I yeah, I'm just confused on how you tweak the ELO parameters because when I look at this guy's ELO stuff, I think this looks great, and ELO does seem to be the standard model for predicting games for sports. Um, yeah, the ELO is the base of the team's strength. Um, Okay, so I guess I'm getting too involved in this. I'm just thinking, so if the ELO, how did you get the ELO is what I'm wondering. The ELO, I get that ELO gives the strength of the team, but you didn't just use there's like a simple formula for updating. elo update formula. Where is it? Right here. Oh, no. Oh, Chat GPT. Chat GPT is not going to help min tasks. I mean, I don't think. We could try it, but that's not going to. Chat GPT isn't going to tell me how to tweak the hyperparameters to get a elo. But you can tweak the parameters to determine. Oh. So if you tweak the parameters for an away win or goal difference, expected goal difference. I see. You can tweak the amount of points gained or lost by a team and equal. So I see. So you used elo ratings to feed it into your machine learning model, and then you used the output of your machine learning model to update the parameters that determine the elo rating. Is that right? Nice. Cool. We figured it out. Cool. Thanks, Gojira. Um, Man, that was great. Yeah, that was great. Okay. Um, cool. So I have some stuff for building up an elo system. Man, that was nice. So uh, how to build elo system. Um, Random elo params. Feed elo scores into predictive model. Tweak elo params with uh, predictive model output. Cool. Thanks. Yeah, of course. Awesome. Thanks. Thanks for subscribing, Gojira. Uh, I'm hoping to. I'm really only live streaming this so I drive progress on it and that I get stuff done. So I would love to collaborate. I love numbers, betting. This is all I do. So anyway, collaborating would be great. Thanks. All right, so let's go try to plot our region. Um, yeah, dude, we lucked out. I don't know how the algorithm works. It was I was lucky to get you viewing. Um, oh right, so we're trying to reorganize this. So my wins, now we have my wins. And do the same thing for losses. All right, my wins. Now let's do my losses. For C-val in losses of 0, my losses, pen. All right. Um, so now we have that for items. So now we plot all the wins and losses. Now region losses equals for item and win loss data dot keys. Okay, so then the color of the bounding box we want to be red because last time it was ugly when it wasn't. Um, and then we want to say we're going to also plot my wins, and we're going to say that that is my wins. So I guess we could say for win in my, oh man, yeah. Um, I guess we want all x values and then all y values. Oh, okay. So this goes through all the wins. Okay, so my wins should be a list containing two empty lists. Now, for cval in wins of 0, if um, get my wins, get bets in region. Oh, my wins. Oh, that's right. That's what I was trying to do. Not plot, just get the bets that are in the region. So now I have my wins and my losses. Now, region wins is equal to, oh, okay, so I define that down there. Now, region losses is equal to self dot get bets in region of losses bounding box. Get bets in region for bet region bets equals such and such for bet and bets. Point of bet 0 and then bet of 1 for bet in bets. No, that's not going to work. Each bet has to contain a point. So, region losses. So pass in my losses. And then region wins. Self dot get bets in region of my wins. And our region is bounding box. Um, okay, so um, plt.plot. Now we're going to plot win of 0 for win in region wins is the first thing. And then we're also going to plot win of 1 for win in region wins. Um, and then color, I don't know what color to make it. Everything's blue or orange, so I guess green. Um, and then we want to do the same thing. Loss of 0 for loss in region losses. And then the other one is loss of 1 for loss in region losses. Okay, and then the label would be bet taken and lost. And then this would be, the label would be bet taken and won. And then scatter plot of wins and losses. Label. Okay, that's fine. Bet taken and won, bet taken and lost. Um, I think that should be good. Then we plot the region. Um, color. I don't even know what other color to make it. Matplotlib colors. Um, Magenta. That might be our one. All right. So let's make it magenta. Green means we took it and won. Red means we took it and lost. Then the bounding box should be blue. So first it does blue, then it does orange. Um, okay. Just make the bounding box cyan. All right. Now let's see what that's going to plot out for us. For C-val in wins of 0. Oh. We forgot to enumerate. So for C-val in enumerate wins of 0. And then for C-val in enumerate losses of 0. Then let's go in here and run the file again. My wins dot append. Oh, my wins dot append. And we want to append val and then wins of C. So I guess we should make this a tuple or a list. And then we're gonna append a little list here. Cool. Now let's try running it again. 1949. Val wins of 1 of C. What? I don't even understand what my line 98 in plot region. My wins dot append. We're gonna say that win is equal to that now. Wins of 1 of C. Yeah, what's the issue here? Same thing. Win is equal to val wins of 1 of C. For C val and enumerate wins of 0. Print C and val. Okay. Back here, run it again. Why are there so many nan values? Not gonna figure that out now on this stream, but we're gonna add that. Why are there so many nan values in win data from analysis 1, trend 3? And then this one, we're going to give it the highest priority. And then move it up there. All right. So that's just something to look at in the future. Now, for cval and enumerate wins of 0, let's just put the debugger in here and go take a look at it. So len of wins of 0, len of wins of 1, so they're the same length. For cval and enumerate wins of 0, print cval win equals val, comma, wins of 1 of c. Wins of 1 of 2000. 1948, that works, and 1949 doesn't work. 1950 works. Wins of 0 of 1949. Okay, I'm just confused. Let's see if there's a way to zip Python zip together two lists. Yep, that's what I want to do. Zip. So we could zip two lists. Type wins 0. Dot values dot to list. Okay, so can we zip wins 0 dot values dot to list and also wins wins of 1 dot values dot to list. We zipped it together, but I still don't get, oh, list, turn it into a list from a zip. So, hell yeah. All right. Now we're cooking. Now we're cooking with gas. So, could take all this shit out. My losses, my wins for item and win-loss data. Nice. So we could just say my wins is equal to list of zip of wins of 0 dot values dot to list. And then we also want to get wins of 1 dot values dot to list. Dot values dot to list, that's the zip, so put it in right there. And then I'm going to do the same thing, but call it my losses and get it for the loss data. So this here should be losses. This should be losses. And this should be losses. All right, now that is nice. Where's the debugger? Did we take that out? Hell yeah. Oh, well, that's a big mess because it's drawing a line. Okay, we're close. Um, we don't want to do plt.plot. We want to do plt.scatter. Oops. Um, plt dot scatter and run it one more time. All right, cool. So this drew us a random line at let's go see the whole bounding box. So yeah, we can see that this bounding box is way bigger than we'll ever need it to be because all our data is way up here. Um, I mentioned, so this is the line we already had, and we wanted to say, hey, get a vertical line. And for that vertical line, get points that are in this region. And that's what it's done. So now we have in red that are the bets we took and lost that are in that region, and then in green are the bets we took and won that are in that region. So let's try real quick moving it up more. Let's get risky and say, hey, let's move it all the way up there to, let's just put it at 0. Um, xint. So we're going to change the x-intercept to 0. And we're going to say, let's get every bet in that region. And then plot it. And sure enough, now the x-intercept's at 0. Now we've taken a lot more bets. And including all of these bets that have screwed us. So nice. So yeah, so we've written code that will return whether a bet is in the region or not, and we've also written code that will return whether the bet won. So in orange are the bets that we didn't take and lost. In blue are the bets that we didn't take and won. In green are bets that we took and won, and in red are bets that we took and lost. And then we have the ability to split up the training and test data however we want. So the next step will be to write some code that outputs uh, how much money you make for that region. So this we've done. Um, Now we need to add in here. Oops, what just happened? Did I exit out of that? Maybe I did. Okay. So the new thing we want to do is write function that returns the net that gives the net return for a group of bets. And that's high priority. And unfortunately, it's also bottlenecked. And it's bottlenecked until we have until we update get analysis function. Okay. And then, okay, so put that in bottlenecked. And this is also a bottleneck reliever because it relieves the bottleneck on the next one down. And then this one, so update get analysis function to include all relevant data about the bet. Then parentheses, not just the odds swing. Okay, and this is high priority, and it's also a bottleneck reliever. Okay, so that's the stream for now. We now have this function that will give us the bets that we've figured out how to define our region, and then we also get the bets that were in the region. In green are the bets that were placed that we would have placed using this strategy that won. In red are the bets that we would have placed using this strategy that lost. Thanks for watching. Next time, hopefully, we'll be able to automate this analysis and determine whether this is a useful trend. Thanks again.